Hi, hello everyone and dear children. Once again welcome back to Teaching and Learning STEM Concepts. Before entering into the video, please consider to subscribe my channel and click on the bell icon for more interesting upcoming videos. Hello students, once again I welcome you all to this wonderful video lesson that we are going to talk about in the today's topic, counting figures, logical reasoning, math tricks. Counting of figures are the most frequently asked reasoning questions in all the competitive exams like NTSC, RRB, SSC, etc. This counting figure problem seems to be too difficult initially if we don't have an idea of how to solve them. So in this video, we will be talking about some shortcut methods for counting figures problems. In these questions, usually we can see a shape in the given figure and we have to count that particular shape in the given figure. That means we will be required to count the number of fixed shapes. For example, you can see in all these figures, here the given figure is a triangle and we need to count the number of hidden shapes present in all these figures. Here the given figure is a triangle and we have to count how many number of triangles are present inside the given triangle. That is our task. Let us see some common popular figures. So here we see a shape in the given figure is a triangle and we need to count the number of triangles present in each figure. Now let us start with what we are going to study in the today's class. So here we are going to discuss the different types of questions with counting the number of triangles in the given figure. So what are the types of questions with counting number of triangles? So in the first type of the question, we will see a triangle and how to count the number of triangles present inside the given triangle when the triangle is divided by the vertical lines. And in the type 2, we need to count the number of triangles present in the given triangle when the triangle is divided by the horizontal lines. And in the third type, we are going to count the number of triangles when a triangle has both vertical lines as well as horizontal lines. So in this type, we can see both vertical and horizontal lines. And in the fourth type, when a triangle has an inner triangle and this inner triangle is touching all the edges of the outer triangle. So in the type 5, we are going to count the number of triangles in such a case that when a triangle has an inner triangle which is touching all the edges of the outer triangle and also has lines coming from each vertex of the outer triangle. And also the vertical lines are touching the edges of the inner triangle. And in the sixth case, we are going to count the number of triangles in such a case that when the triangle has multiple triangles made on horizontal lines. So these 6 types of questions we are going to solve with tricks in this today's video lesson. For better understanding of this concept in this video lesson, please don't skip the video anywhere and try to watch the full video. Now let us discuss the type 1 question. Here you can see 2 triangles. In these 2 triangles, we can observe that the given triangle is divided by the vertical lines. So before going to count the number of triangles, let us name this triangle. Look at here students, from where the vertical lines are coming, the vertical lines are coming from the vertex of this triangle. See, we can see all the vertical lines are coming from the vertex A of the triangle. These vertical lines are dividing the given triangle into multiple triangles. Now we need to count the number of triangles present in each figure. For this we have to do simply 2 steps. Now let us focus on this simple triangle. In this simple triangles, what is the base of the triangle? It is BC. BC is the base of the triangle. So in the first step, just we need to count the number of parts in which the base of the triangle is divided. Here the base of the triangle is BC. So this BC is divided into how many parts? 1, 2. So it is divided into 2 parts. And the next step is just we need to add these 2 numbers. 1 plus 2. So 1 plus 2 is 3. So how many triangles are present in the given figure? There are 3 triangles. So simply we have to count the number of parts of the base of the triangle in which it is divided by the vertical lines. And then we need to add those 2 numbers. Now let us check what are the 3 triangles present in this figure. Now let us count what are those triangles. Triangle ABD, triangle ADC, and triangle ABC. So totally how many triangles are present in the given figure? There are 3 triangles. Similarly, we can also follow the same procedure in this figure also. Here in this figure, what is the base of the triangle? The base of the triangle is BC. So we need to count the number of parts of the base of the triangle in which it is divided by the vertical lines. So this is 1 division, 2, 3, 4. So the base BC is divided into 4 parts: BD, DE, EF and FC. Now in the next step, we need to add all these numbers. 1 plus 2 plus 3 plus 4. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. So how many triangles are present in the given figure? There are 10 triangles. Now let us see what are those 10 triangles present in the given triangle ABC. The triangle ABD, triangle ADE, triangle AEF, triangle AFC, triangle ABE, triangle AEC, triangle ADF, triangle ABF, triangle ADC, and bigger triangle ABC. So one bigger triangle. The triangles involving 3 divisions are 2. The triangles involving only 2 divisions are 3. The triangles which are involving only 1 division are 4. So 4 plus 3, 7, 7 plus 2, 9, 9 plus 1, 10. So without observing all these hidden triangles, just simply you need to note down how many number of parts the base of the triangle is divided, and then you add all those numbers. Then we get the total number of triangles present in the given triangle. And here I am also giving a formula which we need to use to count the number of triangles present in the given triangle when the triangle is divided by the vertical lines. So here I am writing the formula: n into n plus 1 by 2. So to count the number of triangles present in the given triangle, we can use this formula: n into n plus 1 by 2, where n is the number of triangles inside the main triangle, where n is the number of triangles present inside the main triangle. Now let us apply this formula. Here what are the triangles present inside the triangle? There are 4 triangles. So 4 into 4 plus 1 by 2. That is equal to 4 plus 1 is 5. 5 into 4 is 20. 20 by 2 is equal to 10. And here also, what is n here? It is 2. How many number of triangles are present inside the triangle? There are 2 triangles. So n into n plus 1 by 2 is equal to, there are 2 triangles present inside the figure. So 2 into 2 plus 1 by 2. That is equal to 2 into 3 by 2. The answer is 3. So there are 3 triangles present in the given figure. So either we can follow this procedure, or you can also apply the same formula. So to calculate the number of triangles present in the given triangle when the triangle is divided by the vertical lines, we can apply this formula n into n plus 1 by 2, or else you can also follow this procedure. Just you count the number of parts in which the base of the triangle is divided, and then you add all these numbers. Without remembering this formula, you can follow this procedure. Now let us move to the next type of question. In this figure you can see what is the horizontal line here. DE is the horizontal line, and this horizontal line is dividing the triangle ABC into how many parts? 1, 2. So just you count the number of horizontal lines present in the given figure. This number would give the total number of triangles present in the given triangle. So here the number of horizontal lines are BC and DE. There are 2 horizontal lines. So the number of possible triangles are also 2. Now let us see what are those two possible triangles. Triangle ADE and the triangle ABC. Now let us move to the next figure. In this figure, you just see how many number of horizontal lines are present in the given triangle ABC. There is the first horizontal line BC, the second horizontal line FG, and the third horizontal line DE. So how many number of horizontal lines are present? There are 3 horizontal lines are present in the given figure. So there are 3 possible triangles present in the given figure. So what are those 3 possible triangles? Triangle ADE, triangle AFG, triangle ABC. So the total number of triangles present in the given figure are 3. The number of horizontal lines will be equal to the number of possible triangles present in the given triangle. Now let's move to the next triangle. In this triangle also we need to write how many number of horizontal lines are present in the given triangle. This will be equal to the number of possible triangles. So there are 5 horizontal lines. So there are 5 possible triangles present in the given figure. Now let us note all those possibilities. Triangle ADE, triangle AFG, triangle AHI, triangle AJK, triangle ABC. These 5 triangles are the hidden triangles present in the given figure, triangle ABC. With all these examples, we can say that when a triangle is divided by the horizontal lines, then the number of horizontal lines present in the given figure represents the number of triangles present in the given figure, that is, in the given triangle. Now, we can move into the third type of triangle. In this triangle, we can see the triangle is divided by the vertical line as well as the horizontal line. What is the vertical line present in this triangle ABC? Here the vertical line is coming from the vertex A. So AF is a vertical line, and there is one more horizontal line DE which is dividing the triangle ABC. So the vertical lines AF and DE are dividing the triangle ABC into multiple parts. Now we are going to calculate how many number of parts this triangle is divided. Now in such a case, we need to follow a formula n into n plus 1 by 2 for the vertical lines multiplied by the number of horizontal lines present in the given figure, that is the given triangle. We can use this formula n into n plus 1 by 2 for vertical lines multiplied by number of horizontal lines present in the given figure. Let us check this formula. In the triangle ABC, what is the vertical line? The vertical line is AF. This vertical line AF is dividing the base of the triangle BC into how many parts? This is 1 and this is 2. So the vertical line AF is dividing the base of the triangle BC into 2 parts. So n is equal to here 2. So 2 into 2 plus 1 by 2 multiplied by how many number of horizontal lines are present in the given figure? Horizontal line BC. BC is the first horizontal line and DE is the second horizontal line. So there are 2 horizontal lines present. So 2 by 2 is cancelled. 2 plus 1 is 3 multiplied by 2. 3 into 2 is 6. So how many triangles we can see in the given figure? Yes, there are 6 triangles present in the given figure, triangle ABC. Now let us see these 6 hidden triangles present in the given figure, triangle ABC. First, let us see the number of triangles present in the given figure when the triangle is divided by the vertical line. Triangle ABF and triangle AFC. And the bigger triangle, triangle ABC. So there are 3 triangles present in the given figure when the triangle is divided by the vertical line. Now we are going to count the number of triangles present in the given figure when the triangle is divided by the horizontal lines. Let us see. The triangle ADE, triangle ADG, and triangle AGE. So here in this smaller triangle ADE, there are ADG, AGE and ADE. 3 triangles. So this triangle ADE is itself a triangle which is divided by the vertical line AG. So we can see 3 triangles. 1, 2 and this one 3. So totally we can see 3 triangles. 3 plus 3 is equal to 6 triangles. 3 plus 3 is equal to 6 triangles are present in the given figure. So what is the formula which we can use to calculate the number of triangles present in the given triangle when the triangle is divided by both the vertical lines and horizontal lines? This is the formula: n into n plus 1 by 2 for vertical lines multiplied by the number of horizontal lines. Now let us apply the same formula to the second figure. In this figure, first let us write the number of parts in which the base of the triangle BC is divided by the vertical lines AH and AI. This is 1, this is 2 and this is 3. So how many number of parts in which the base of the triangle has been divided? Yes, it is divided into 3 parts. There are 3 divisions: to n into n plus 1 by 2 into number of horizontal lines, capital N, is equal to 3 into 3 plus 1 by 2 multiplied. How many number of horizontal lines are present? BC is the first horizontal line, FG is the second horizontal line and DE is the third horizontal line. There are 3 horizontal lines are present in this given figure. So 3 plus 1 is 4. 4 into 3 is 12 divided by 2 multiplied by 3. 2 6 are 12. So 6 3s are 18. 6 3s are 18. So how many number of triangles are present in this given figure? There are totally 18 triangles present in this second figure. Now let's move into the fourth type of triangle. In this type of triangle, we can see a bigger triangle, and in this bigger triangle, we can see a smaller triangle which is present inside of it. And you can observe that this triangle is touching all the edges of the outer bigger triangle. Now, before going to count the total number of triangles present, first let us name this triangle. ABC is the outer triangle. And DEF is the inner triangle present inside the outer triangle ABC. So in this type of question, to calculate the number of triangles present inside the given triangle, in such a case, we can use the formula as follows. Number of triangles is equal to 4n minus 3. What is n here? N is the number of triangles present inside the figure. Let us see how many number of triangles are present. Here we can see a bigger triangle ABC, this is the 1, and we can see a smaller triangle DEF, 2. So 4n minus 3 is equal to 4 into 2 minus 3, 4 2s are 8 minus 3, which is equal to 5. How many number of triangles are present in the figure? There are 5 triangles. Now let us check all these 5 triangles. Triangle ABC and triangle ADE, triangle DBF, triangle EFC and triangle DEF. So there is one bigger triangle ABC and there are smaller triangles 1, 2, 3, 4. So there is one bigger triangle and 4 smaller triangles. So 1 plus 4 is equal to 5 triangles are present in the given figure. Now we apply the same formula to the second figure also. Now let us calculate the number of hidden triangles present inside the figure by applying the same formula. 4n minus 3 is equal to how many number of triangles are present inside the figure? Let us count. The bigger triangle, this is 1, and there is one smaller triangle which is touching all the edges of the outer triangle 1. This smaller triangle present inside the figure is touching all the edges of the outer triangle, and there is one more triangle present inside the inner triangle, and we can see that this triangle is also touching all the edges of the inner triangle. So this is third one. So how many number of triangles are present inside this figure? 3. 4 into 3 minus 3. 4 3s are 12 minus 3. 12 minus 3 is 9. So how many number of triangles are present? There are 9 triangles. Now let us see all those 9 triangles. So here the smaller triangles 1, 2, 3, 4, 5, 6, 7 and the bigger one 8. And this one 9. 1, 2, 3, 4. There are 4 smaller triangles, and 5, 6, 7 and 9 there are medium triangles and one bigger triangle. So there are 4 smaller triangles 1, 2, 3, 4 and 4 medium triangles 5, 6, 7 and then 9, and there is one bigger triangle 8. So totally 4 plus 4 plus 1. So there are totally 4 plus 4 plus 1. There are 9 triangles present in the given figure. So the formula which we can use to calculate the number of triangles present inside the figure when the triangle has an inner triangle which is touching all the edges of the outer triangle is 4n minus 3. Now let's move into the next type of triangle. In this type, we can see a triangle. In this triangle, we have an inner triangle, and this inner triangle is touching all the edges of the outer triangle. And inside this inner triangle, we can also see another triangle, and this triangle is touching all the edges of the inner triangle 1. Actually, this type of question is the extension part of the previous question. So what is the difference between this question and the previous question? In the previous question, we don't see any vertical lines coming from the vertices of the outer triangle. We can also see here lines are coming from each vertex of the outer triangle. So here we can observe that the inner triangle is divided by the lines coming from each vertex of the outer triangle, as well as this inner triangle is having one more triangle which is touching all the edges of this inner triangle. So if you want to count how many number of triangles are present in the given figure, first we ignore the lines coming from each vertex of the cone. Then we can see the picture like this. Now this would be similar to the previous question what we have discussed in the previous question. An outer triangle has an inner triangle, and this triangle is touching all the edges of the outer triangle. And this inner triangle is also having one more triangle inside of it, and this triangle is touching all the edges of the inner triangle. So in this case, how many number of triangles are there? As we can see in the previous case, we can see this is the first one, outer triangle, and this is the inner triangle, and inside of this inner triangle we can see one more. So how many are there? So 4n minus 3. The total number of triangles present inside the figure are 4n minus 3, which is equal to 4 into 3 minus 3. 4 3s are 12 minus 3, which is 9. So there are totally 9 triangles present in the given figure. Now I am going to note down what are those 9 triangles. 1, 2, 3, 4. There are 4 smaller triangles, 5, 6, 7 and this one 8. 8 medium triangles, and the bigger one, this is the bigger one, 9 triangles. So there are 4 smaller one, 4 medium triangles, 4 smaller triangles, 4 medium triangles and 1 bigger triangle. So there are totally 9 triangles are present in the given figure. Now you look carefully. In addition to this part, we are having lines coming from the each vertex of the outer triangle. In the triangle 5, a line is coming from the vertex of the triangle. So this line is dividing this triangle 5 into how many parts? 1, 2. It is dividing into 2 parts. In a similar manner, the triangle 6 is dividing by the line coming from the corner of the outer triangle. So this is also dividing the triangle 6 into how many parts? 1, 2. Similarly, the triangle 7 is divided by the vertical line coming from the corner of this outer triangle. So it is also dividing the triangle 7 into how many parts? 1, 2. So there are totally how many parts? 1, 2, 3, 4, 5, 6. There are 6 triangles. So if we consider the lines coming from each vertex of the main triangle, we can see there are 6 more triangles present inside the figure. 6 more hidden triangles present inside this figure. So total number of triangles present in the given figure are equal to 9 plus 6 is equal to how many? 15. There are 15 triangles present inside the figure. So there are 3 triangles, 5, 6, 7. These 3 triangles are divided by the lines coming from each vertex of the main triangle, and these lines divide each triangle into 2 parts. There are 3 such triangles, 5, 6 and 7, which are divided by the vertical lines into 2 parts. 3 into 2 is equal to 6. So the total number of triangles present in the given figure are 9 plus 6 is equal to 15. Let us move to the next question. In this type of question, you can see a main triangle. This main triangle is divided by the horizontal lines. If you observe carefully, you can see multiple triangles inside this main triangle. And these smaller triangles are made on the horizontal lines. And if you look closely from the edge, from every edge, we can see equal number of triangles. This base is having 1, 2, 3, and this base is also having 1, 2, and this is 3. This edge is also having 1, 2, 3. 1, 2, 3. So if you look carefully, each edge of the main triangle is having equal number of triangles. And the triangle is divided by the horizontal lines, not by the vertical lines. In the previous type of questions, if you understand the concept very well, you can calculate the number of triangles present inside this figure also. So my dear students, you count the number of triangles present inside the figure and let me know the answer in the comment section of this video. Then we can meet in the next video with another type of questions, with another puzzles. Until then, please keep watching my channel. Subscribe to Teaching and Learning STEM Concepts.